Hello, people. We'll be starting soon. Why don't I put my chat up? That sounds like an idea. Then I can see all the informative things that people in chat are saying. Except, wait, my browser just isn't opening the Twitch dashboard. It's just not. It's not going to Google. It's not going to Twitch. Oh, there we go. Yeah, why am I thinking computers might work? It's a very silly idea. You have cured your project from STDs yesterday, and now it is running 3 times faster. I mean, if you were able to make it 3 times faster by doing that, I'm sure you could make it several times faster still by doing other things that are not even crazy optimization. We're going to save computers. Don't worry about it. It's just going to take some time. I think we could save computers, maybe. Your Weissman score for pull-ups is up to 5. That's good. I'm going to do some more pull-ups later tonight. Last time I was at 7 barely, I think. Maybe it was like 6.95. Okay. So, I have my set of ideas that might make more gains, and I'm ready to execute on one of them. And I'm hoping the gains will be good. They might not be good, though. They might be lame. Let's just see. Let's try this. Okay, so okay. That's probably not huge gains, but possible gains. Oh, we need debug compiler if we're going to get a Weissman score report. What factor of increase in work performed does the final shipping period of game development usually have? I don't understand the question. In work I mean, it's not like there's a fixed amount of work to do and then suddenly there's more later. It's just shipping is, you always had to do the work to ship the game, right? That's why I don't quite understand the question. If you mean like how many hours per week or something you work, well, that assumes a known ship time. Oh! Okay, interesting. Interesting. This means I probably have an error in this, right? So if I comment this out, we probably don't crash. Okay, so I added this dominating tree. Oh, I didn't check. Right, I forgot something. Shoot. Yeah. Okay. Instead of recording this separately, we could record the time at the instruction index during which it's created. This is a case where having more fine-grained basic blocks would matter. Yeah, how crunchy the crunch periods are depend on whether you pick your, it depends on whether you pick your ship date first and then try to finish the game, or whether you try to finish the game and then pick your ship date. And I usually do the second one. Okay. Yeah. I thought we had a getter for we don't. Oh, I forgot about this. Yeah, so let's not do that. Where was I? Finder add empty array, and I want to say instructions.count. Okay. Oh yeah, and then I didn't put it there. Okay, so maybe this will work better. Did I okay. Why did our Weissman score go up, guys? This doesn't make sense. I was doing... Oh, because we're not finding it. Oh, whoops. Okay, I did this wrong in a couple of ways. So we need this. And then we need okay. This should, if I didn't screw it up, be a strict reduction in Weissman score. Okay. That's more like it. Let's make sure it runs. Let's run it a couple times. 676 301 253. We'll take the 301. It's in the middle. Okay. I believe that is beneath our yesterday's low Weissman score before we regressed. While dominating equals dominating, arrow dominating, what? That's correct. What are you talking about, Willis? Will I ever get tired of gaining? Maybe someday. Maybe someday, but not today. For a while. All right, now, the thing about that gain that we just did is that that was a gain from the structure of having this dominating flow graph. And what that means is I can apply this gain to several other places. All these finds are let's do emitted constant. So when we find an emitted constant, we can do the same search. I say return it.value number, I guess. All right. So we need to save the instruction index. Yeah, no, it's okay. Okay, so we need to then do that. Emitted constant. Let's make this shorter. Okay, let's see if I did that correctly. Look at that. Look at that number. What do we have to say about that number? Let's make sure it runs. Now, because the number fluctuates, oh, it doesn't run, guys. So that doesn't count. In fact, actually, we never ran all the tests on the previous. So let's not get ahead of ourselves. Okay. So first, when we fix that bug, the gains might not be as big. But secondly, okay. So this loop might still be wrong a little bit. Okay, so we're just going to go BB arrow constants, return it.value number. In principle, all right. I don't think I ran all the tests. So let's do that. And then we'll try to figure out why what I did is wrong. I mean, it looks fine. We might, though, because, so this might be a case where this is correct, but we're using an emitted constant. We're assigning an emitted constant to something that then changes. And that bug would have already been a bug, but it just might not be exercised, right? We might not be encountering that bug. And then once we more aggressively reuse constants, maybe we're encountering that bug. Okay, so here we're going to commit, we're going to say improved Weissman score involving empty arrays. Okay. Okay, let's put this back. I'm actually pretty hungry. I might have to make a little protein breakfast here. Some bacon and eggs, something like that, you know. Okay, so this, let's do it on the tests. Maybe one of these will fail. Soylent, I don't think dudes who really want to make gains do Soylent. All right, simple string, line 104. Isn't that the same place that I had problems with? Oh, God. I mean, this is just sort of a place, because I think there's an assertion there, it's a place where problems get noticed, right? Let me just try the game again. Boy, that gains number sure looks nice. We got to earn it, though. Got to earn it. Let's see where we crash. That's a breakpoint. Count is equal to a big, crazy number. Count is, it looks like a string or something. No, not really a string. I don't know what that is. That looks like actual data that someone is using. Okay, well, let's find, if we can find where it goes wrong, we can then dump that function and look at what our intermediate representation is doing wrong, right? So stir is, looks fine. Suffix is probably wrong, right? Yeah. Okay, well, suffix is a string constant here. So what I could do is verify that it's wrong there, right? So, I mean, still, because our x64 code generator, it's better than it was, but it's still not great. Like, there's just a lot of verbosity here. But so we're doing a bunch of stuff. And then we should have a call. Here's the call to ends with here. So the thing right before that is going to be, okay, so these putting things into RSP and RSP plus 8 are the two parameters, value.fullPath and config. So config is RSP plus 328. So let's see. All right. So this is going to just be something random. It happens to be a string right now, but it's going to be overwritten by this. So okay. So we're putting something R9. That sounds bad. Because we just put doesn't make sense to me. Hold on. Oh, no. That's the address of the thing. Okay, hold on. It's actually this is the address of the string. So that's uninitialized yet. I think. So R10 and R11. Maybe. So R10 is this giant messed up thing. I actually kind of just want to dump this and also start my eggs going. All right. So what are we dumping already? We could turn that off. It's in Baker, right? It's in Baker. Yeah. Okay, so we want to look at perform reload or creation line here 226. So we could just do that. Let's put that to a file. Well, I guess today is bacon day. I just put 10 slices of bacon in the pan, NBD. Was the LLVM debug fixed on last stream? Yes, it was. Or maybe before last stream, but it was fixed. Okay. Failed to set the icon as expected. So the deal is on Windows, you can't overwrite an executable that's running, and we have this open in the debugger. So I was not expecting this to succeed. What I was just doing is writing this output file. Except we didn't get a dump. Did I not? I thought I put the dump. Oh, I put it here, and then I didn't. Oh, guys. Okay. Perform reload or creation is polymorphic, and we probably don't copy the dump flag when we polymorph. Lambda debug dump. Yeah. Okay. So now, though, the consequence of this is we will get multiple dumps, but they're probably all going to be the same for the purposes of what we actually care about. All right. There we go. Okay. So we wanted line 226, I guess. Okay. So let's sort of look at it over here. Actually, let's look at it in this. 226. Okay. So we have an if statement. We're calling ends with and so forth. So we get a string . So we have V56 is a Lee. We're just not ever writing the value number. Wait, no, V27, that's what it is, right. Sorry. This wraparound was... So, okay, we think V27 has a 3 in it. Okay? So we could first skip up here and look for V27. It's got a 3 in it. Does that change? No. So why doesn't it have a 3 in it anymore? Block 4, block 3. Okay, so in theory, okay. This dominating is wrong. I might have a fundamental screw up. Okay, so the problem is this is supposed to say, hey, to get here, we had to come from here. But it's not true because we jumped from here. For example, and if that's wrong, lots of other things could be wrong. It says instruction 49. So I need to figure that out. We're putting the fan on for the bacon. It doesn't need to flip yet. The pan took a while to heat up. Sorry for the delay. I just had a lot of bacon to deal with. There was a lot of bacon. More bacon than I've ever made in my life. Mmm. Did I see the stuff with GameStop? No. I saw that today's money stuff was about GameStop, but I didn't look into it. There are very few things that I care about in this world less than GameStop. Hello, rating people. We're in the middle of me finishing making some eggs, but we will be programming again in a little bit. Pretty soon. Doing the green chili sauce again. I'm just not making as much of a presentation out of it. I pushed GameStop stock up 1,700%. The short sellers have lost billions. Yeah, I mean, I'm okay with that. The thing is, it's not like the people pushing the stock up are being productive either, but at least they're not betting on companies failing, because betting on companies failing does create very bad incentives when they get large enough, you know. What is Indie Fund up to? We're funding games. Most recently, Slipways, which is going to be on Steam as a free demo on February 3rd as part of the Steam Game Festival. What is a good Weissman score? 0. What score do I think is possible? I really don't know. I mean, it is probably not possible to get to half of the current number without being a jackass. Three-quarters of the current number, maybe, but I don't know. I would have to look at a lot more code. Is the rest of the team working on the game, thereby destroying my gains? Well, they are working on the game. I am not updating the game for now. I mean, I will in a couple days or whatever. But for now, I am intentionally not updating it in order to keep my number stable. Will I battle with Forecoder today? Maybe. I mean, I'm not sure. It depends how I feel about it. Did they make the big announcement that was announced that there would be an announcement? Is Tencent buying Forecoder? What's going on? Do we reshuffle entities or scan through looking for empty slots? We scan through looking for empty slots, which can be made very fast by just knowing which bucket has the first empty slot. Okay. So the question is, why are my dominating blocks wrong? It's no surprise that they are wrong because I just put them in this morning before the stream. So GG's me for making a bug. Send a repro and a fix for file utils. Okay, cool. Yeah, one of the things I want to do is go through the mailbag tonight and fix most of the bigger issues. And then, because it's been a little bit since the last beta, because this beta has so many huge changes, maybe I'll label it as like precautionary when I put it out. Like, if you're happy with the current beta, maybe don't grab this one because there's a possibility of things destabilizing. Although, I mean, it works fine for me, obviously, but yeah, anyway, we'll get this out there with some mailbag stuff soon. Do I think languages like Clojure have any place for low performance server code? Do you mean almost all code? Almost all code, not only in the web, but outside the web, is low performance in that it's tremendously slow compared to how fast it should be. So I don't know what you mean by low performance server code. It's all low performance. You mean I want to save my tiny notes file? Why is that even server code? Like, I don't understand the scenario. But no, I wouldn't use Clojure for anything because, like, why should I use 7 different programming languages? Like, use one, pick one that you want to be good in and use that for everything. Or maybe not 100% of everything, but like almost everything. Like, you don't need 7 different programming languages. You need at most 2. At most. Whenever you write extremely trash code, it's still faster compared to similar programs. You literally don't know how that could happen. I mean, it's somehow it does, right? Like somehow this code everybody writes is so bad. It's worse than the default thing you would write if you just didn't care how fast it ran. Like somehow people do worse than that. What's my second language? I don't have one. I mean, I'm programming the compiler in C++, obviously, but that's because I have to for now. Do I think data science and machine learning types could benefit from their workflow to statically type compiled languages? Okay, look. If there is some code in a non-statically typed language and it claims to be science in any way, disregard all results of that code because it's probably full of fucking bugs. So yes, if somebody thinks they're, by the way, data scientist is just a phrase that means advertising bean counter, right? But if you're just not doing science if you don't have a statically typed language. Can I imagine any possible case in which I would think the penalties imposed by using dynamic languages like Python are worth it? No. No. The answer is no. Okay, let's get back to programming. So I just said, okay, where were we? We were at line 226. 18 bacons ago, okay, we're saying dominating block 4 instruction 49, which is obviously false because we have a jump there from block 3. So I hope that my fundamental concept is not wrong. Let's see. So this block 3 jump is line 3476 in bytecode builder. So it's the else block of an if statement on line 212. I need more windows. Okay. So okay. So basic block 4, I kind of don't understand why there aren't more basic blocks. So we're in block 5. Block 4 is 218 to 220. That's this else block. Yeah, there's no way that that can be dominating because okay, I think what's happening is we're like somehow not. We're eliding an empty basic block or something. Oh. That might. I don't actually want to. Okay, so we have this old block illusion, or this empty block illusion, and I don't want to think about how that might be messing with things. So let's just take that out for a second. Hey, look, the game works now. We're over 350, but not by much. Let's Yeah, see, the problem is we need... Let's go back to this exact site where we were. We need those empty blocks, kinda. So we're at 226. So now I'm not sure. I'm not sure why that changed radically. Like, I know the empty block elision was screwing it up, but I'm not sure why. Is it because we were just setting those? Oh, maybe because we add basic block and then do stuff and then come back and stuff the pointer. Okay, maybe. Let me write that down as a place to investigate. But it's not very important. The basic blocks do not count in our Weissman score because they have no code in them if they're empty. So we're about to make some gains, I think. I mean, let's see. Running the tests. We'll go back here. We'll take out the no check-in. I'm going to put this note for elision that maybe we care about that. There might be a simple fix to this. Wait, why is it? Oh, I'm running LLVM tests for some reason. That's fine. They'll just take a little longer, but we're gonna celebrate our gains while that happens. So 350074. 350185. 350079. We'll take the 079 on the scoreboard if the test's complete. I'm going to hope they do. 350079. Guys, look at those gains. Look at those gains. We've already beaten yesterday's entire day of gains. It was like 2,000 yesterday. Yesterday did end up being a bug snacks day. It's true. That's not what I intended it to be, but it was. But the good thing about a bug snacks day is that you get to have some bug snacks, which we did. How much faster does the game run? Good question. Let's wait till these tests finish. There we go. Let's run the game. It's probably about the same because that was like a 1% improvement. So you don't necessarily expect to see the gains in the frame rate, you know, from 1% to 1%. Like, for some reason it's actually in the 17s right now instead of 18, but like again, like I don't even know what processes are doing anything. I don't like it. Things are unreliable. Windows audio device graph. That's great. I'm sure glad the Windows. Oh, guys. I didn't know my machine was running killer network service. That might be why we F sometimes, actually. Do you guys know that? That's what killer network driver does, is it literally kills your network connection sometimes. Because they're like, oh, this is for when you're gaming, so if there's a lot of bytes going, that must be a download. So maybe that's it. Why would anyone? Well, the idea is, again, if some service decides to download too many bytes while you're trying to own noobs in Call of Duty to keep you owning noobs, the problem is games do that sometimes. Oh my God, look how bad a modern computer is, guys. I literally don't want any of these things. I'm sure glad there are several NVIDIA containers running. That's great. Adobe installer. Look at all the Adobe software that I'm installing right now. Radeon software. I'm using an NVIDIA card. Autodesk desktop app. Boy, look at all these NVIDIA containers, guys. That's great. NVIDIA is really helping us carry our packages. Why are there 13 Chrome threads? I don't know. I have like 5 windows. Steam client bootstrapper. Let's get rid of that. All right. Anyway, none of that really mattered. Okay. The point is we got our gains and we're going to continue getting gains. We'll leave the old code. Because this is a little more complicated, All right. Two chains. All right. So the thing is, we get to keep doing this trick, guys. String literal maybe we'll do, but I think the big one. Oh, Varg's array might be. Caller locate. Look at all these finder emits. Let's do the Lees. So the thing about the Lees is they already had like a hack. And we're not going to need the hack anymore. Okay. So we're going to get rid of the top level Lees. This was a stupid thing. Okay. This is good because we'll get back some code simplicity. All right. So, same deal for dominating arrow lees. Okay. And then we need to go. Okay, and then that. Emitted Lee. Like that. Current instruction. Oh, it's just yeah, that. Okay. Whoa, Nelly, 347895. I wasn't planning to do as much of this prep for data flow analysis as we actually have done. So we are able to take advantage of these things. Look at that Weissman score, guys. It's pretty good. Okay. Wow, I never thought we would get anywhere near this much Weissman score. Like 2 weeks? It's been less than 1 week, hasn't it? When did I start doing the Weissman score streams? It wasn't that long ago. I took 1 day off. I think it's been like 4 days of work. 5 days, something like that. It has not been 2 weeks. I guarantee that. How close am I to being done with this sort of optimization? We're not that far from being done. Like we might be done with the Weissman score push today. With most of it. Because we're getting pretty good at this point. Like, at some point we get, diminishing returns off work put in. We sort of hit that point yesterday, But then we had a couple of other major areas to visit, and those areas have been good. Okay. I think I started last Wednesday. Yeah, that could be about right. I mean, the VODs are all up. I don't think I deleted any of the Weissman score VODs. Maybe I did. Can you ask a longer question? Sure. All right. So while you're asking the longer question, I want to check this in, which means I want to get rid of the top level lees because that was a stupid ass hack. I want to get rid of, I mean, it wasn't stupid. It bought us some Weissman score for a while. We're going to get rid of that. We're going to get rid of this. We're going to get rid of temporary do not add lees. We might have actually made code gains on that one. Where are we at right now? Yeah. Let's do a release build just to enjoy. And what are we dumping right now? Is it in catalog? Yeah. So, you know, we're still building in the same amount of time, or approximately. In theory, this dominating block hierarchy thing could be taking a little bit of time now, but I think that is more than made up for on the back end, especially by the time we have optimization. Okay. And also, if it is slow, a big part of why it would be slow would be memory hierarchy things, which can be rearranged, actually. Okay. Yes. Let's just run it. How's the performance of a native debug output compared to LLVM debug output? It is still slower for reasons of all strings and arrays still go on the stack with our thing, and LLVM probably puts those in registers. So that's probably the main perf difference. So we should be able to beat LLVM's debug build actually in the end. So LLVM gets about 22. We could see. Last I recall, they get about 22 FPS there, but they take tremendously longer than us to generate that. Like they take 2.6 seconds and we take 0.6 seconds, right? So they're like 4 times as slow. But let's see. '21, 22-ish, yeah. Mostly 22. So, I think that's totally achievable with our debug backend, without taking much longer, right? So we will. So the problem is, okay. So there's two things. Putting arrays and structs in registers, and then B, I mean, our x64 code gen is just poop, right? It still doesn't have a good register allocator. So fixing that up probably gets us the majority of the way, actually. Yeah. So that would be a different Weissman score to do, but that one's probably more grindy. Whereas this one, we're able to make fast progress sometimes. What? Just take... I don't want this window to be up. Thank you. Do I think a grid-based movement system can be removed so the user does not have to keep pressing the keys again and again to move the character? You don't have to press the keys again and again in this game. You can hold a key and you'll go. That's easy. That doesn't involve removing grid-based. Okay, so I think we can check this in. Let's do release tests just to do them. We haven't done release tests in a while. And then we've still got a couple other things to apply this trick to. Okay. So that's great. Okay. Varargs array. Here we go. Find or emit. Oh no. This one is more complicated. It does a lot of work. And, we might not be able to apply this to this. Right, this is a lot more complicated. I'm going to put that on the gains list as a separate item. It might cause me to go question what some of this complexity is that we did just a few days ago. We probably did this on the first gains day. Okay, I feel like we might come back to this later today. In the meantime, let's do this one. Oh no, this also. Maybe we will use it. Are there any other find or remits? Lee. That's it. Okay, so as far as I know, we have taken this method as far as we can. Until we rewrite some of these things, which I think we may now wish to do. But that was good, guys. This was, yeah. Also, considering we have another big one coming up potentially today, who knows where we're going to get. There's a phenomenon of mobile. Pretty substantial evidence that people prefer and trust more programs that are larger. It seems to be the same phenomenon of if an operation completes faster than the blink of an eye, the user will think it was an error and won't notice it. Something that we created a simple torch app and distributed X version of it, base app 200 kilobytes because we use large images. Like, I don't ever believe any of that stuff. Because all of those things are like all else being equal, and all else isn't equal. Also, the thing about if an operation completes faster than the blink of an eye, the user will think it was an error. That's faulty as well. Like, it's advice given by people who are drawing incorrect conclusions, right? Like if something, like the visual feedback that is appropriate for something that completes immediately is different from the visual feedback that's appropriate for something that takes 3 seconds. If you don't alter the visual feedback in response to the action, that's your fault for having bad UI. So like that's the real thing that's going on with the user will think it was an error, won't notice it. It's not like that's some law of human nature. It's that your UI was shitty. Okay. So like the thing that if you actually start to really understand software, what happens is you start going back and looking at all these things and they're just all written by goofballs. You know, I mean, it's people who mean well, but who are not very serious about their discipline. And the problem is if you promote those things to institutional wisdom, you start degrading the average quality of your institutional wisdom. So be very careful about that. Be very careful about that. I would also put it this way. There's a separate thing, which is In general, my life strategy is to be in the outlier class, right? Like I always had a contrarian personality. I always very quickly saw what I didn't like about the institutional way of doing things or whatever, right? Now that might not be a good strategy for everyone, but for me, it's been an effective strategy. If you are following that kind of strategy, then that kind of advice looks absurd because that's extreme inlier advice. You know what I mean? It's like that's advice for people who have no intention whatsoever of ever even considering being an outlier. In fact, if you follow that kind of guideline, you're preventing yourself from becoming an outlier, right? Which is fine if that's not your strategy at all, but yeah. Blogger famously had an artificial weight. That's bad UI. It's just bad UI. That's all. Okay. So I think I'm going to change the way this works. I'm going to just save my notes here. Let's just run the test to make sure I didn't inadvertently break anything, but I don't think I changed anything. So I'm going to run the tests, and then I'm going to try rewriting the way these work to work the other way. That I should have written them in the first place. Also, I did some laundry so I can fold pants. Commit. Update notes. Okay, so we are going to rewrite this, and so that hopefully it's not that big of a deal to rewrite it, and it results in less complexity. And then we can check that in, and that also won't be a Weissman score reduction. But then once we have done that, maybe we can do this new thing and check that in, and maybe that will be a Weissman score reduction, hopefully. Do I think there's any place for a standardized set of best practices in software engineering? Not really, no. Nope. I mean, there might be a few, like use statically typed programming languages, but they would be a very small number of very high level things. Like, that's really almost the only rule that I can think of that's universal. Use version control? Yeah, probably. Is publishing a book on my bucket list? I have notes here for a book. We might do a book writing stream tonight. What about lower the Weissman score? Maybe. You understand wanting to make it compile a program in under a second, but anything less than that seems to be overkill. Well, how big is the program? This program's 100,000 lines. It takes us, on the order of 1 second to compile it. If you try to compile a 1,000,000-line program, it'll take 10 seconds. That sounds like a long time to me. Why not compile a 1,000,000-line program in 1 second? Incremental compilation can go jump off a cliff. Okay. Okay. Let me just look. Okay. Okay. So, we already do push and pop procedure call. So why don't I just record which ones we're using? Oh, I see. Okay. Let's just do this. I wrote this on January 20. That was probably the first day of Gains streams. January 20. Wednesday, yeah. Okay, we're going to do this differently. We're going to go auto emit procedure stack.peak and I'm just going to make this much more in line with the way everything else works. Value number. Oh, right. Oh no, I forgot about this. I forgot about the fact that we reuse them and don't maybe modify file names and such. That makes it harder. How do you know if programming isn't for you? I mean, I never had that problem, so I don't know. I mean, so you're starting out talking about being good at things, and then later you're getting all emotionally wish-washy and saying you feel deeply punished for trying. Why? What does that have to do with anything, first of all? Like, do you want to be good at something or not? Being good at something involves working hard. Being good at something involves starting from a state of not being good at the thing. So if you decide to feel punished because you're not good at the thing, then you're never going to get good at anything. Because getting good at anything involves starting by not being good at it. Okay? So I think it sounds to me like you have a negative association. Okay. It kind of makes sense. You have a negative association with being bad at things because you want to be really good at things. That makes sense. But you need to modify the association. You need to modify the way your mind responds to this. You need to be okay with being bad at things in the short term. Otherwise, you'll never get good at anything, right? You need to parse that apart in your mind. Being bad at things in the long term that you have chosen not to be bad at is the thing that's bad, right? it's also fine. Being bad at things you don't care about is fine because you can't be good at everything, right? So you just need to modify it so that it's more like the thing that is dissatisfying is failing to improve, right? That you need to change it from the constant value to the derivative, right? So failing to improve is the problem, right? If you're bad at something, but it's relatively easy to improve, there's no problem, right? Because you'll be good before too long. And you can apply that to everything. So like ability to learn is a meta level skill that's very important. And as long as you have that ability to improve, as long as you have ability to improve, you'll get better at most things. So I think you just need to focus on that. Instead of focusing on how good are you right this second, focus on what is your ability to improve. Because that's actually actionable. And that's really the thing to be upset about. So if your ability to improve is 0, then you shouldn't do a thing, probably, right? Like, if I didn't have legs, my ability to be a champion pole vaulter would be very low, right? So maybe I shouldn't decide to do that. But when it comes to something like programming, very few people have a block of that kind. So it sounds like you have a very active self-criticizing voice. That is criticizing you personally. And that is also not helpful. All right. It is good to have a voice like that. People who don't have a voice that is critical of what they do end up not being good at things, right? So it's good to have that. But it sounds like your voice is miscalibrated into personal insults, which isn't going to help you. Personal insults also will hold you back in life, okay? Self-issued personal insults. What you want is for that voice to be more discriminating and to look at quality of what you do and to criticize quality of what you do, because that is changeable and improvable. And that's very important. If you don't do that, you're not really going to be able to get good at things. Probably would be my guess. So it's very important to fix that. Okay. What do I do about this? The thing is, this skip flags stuff is probably optimal. It's probably going to get us a better Weissman score than the other thing. So I think I kind of want to revert this. These changes I started doing. Because I forgot that we were doing this like delta. This one, though, we do a little bit in terms of finding things with the same count. The problem is we can only do that within a basic block. Which honestly, I mean, I guess that was worth it Weissman score wise, but yeah, I don't like this pushing and popping. Okay, so I'm going to revert the other thing, and I'm going to do this one. Whoa. Yeah. Oh, it's Juan. Okay. What's up, Juan? Did you ever tell me about your Huffman threading idea? It doesn't ring a bell. It does not ring a bell. Maybe I didn't understand. Do you mean as in threading multiple streams of Huffman coded data together, or do you mean applying Huffman coding to threads in some way? Hard to imagine that. Oh. No, maybe we did talk about that, and it makes total sense. Like, look. Well, maybe. I mean, it only makes sense to me that if you were designing your bytecode system, and if it's a variable length encoding, which this one actually is not. This one's a fixed length encoding. If it was a variable length encoding, then yeah, you would want to take the most common instructions and make them the shortest ones, right? I do remember we had a conversation about that at one point. The thing about intermediate representations for compilers, at least it makes sense to me that they're more RISC-like than endpoint CPU instruction sets because the reason you have this intermediate representation is not really to run it, although we do run ours, right? The reason you have it is to do logic on the individual units and shuffle them around and turn some into other ones and stuff. And That gets more annoying when things are variable length, which is why I have them be fixed length. But it also gets more annoying when you have to consider a zillion different side effects of a particular instruction, or a zillion different ways of, like, if compares are baked into a bunch of instructions or whatever, right? Now, that said, I actually haven't done a survey of what are the intermediate representations that people use and how many instructions do they have and whatever. So I don't actually know if they're really more risk than CPUs, but this one is. I mean, this one, it's got more instructions than it used to have, but the total set of instructions goes from line 35 to line 137. So we have 100 minus, we have about 85 probably. And some of these really should be one instruction. So like bitwise operation should probably be an instruction. And then each of these 7 things should probably be just a little enum on the instruction, right? Same with math. So we have 90 something, and let's just say we could easily subtract 10 of them. And then some of those are actual CPU intrinsics that we're mapping directly to our thing right now. So in terms of like actual general instructions, we probably have about 70. Is it really that many? Seems like it would be less. 1, 3, 4, 5, 6, 7, 9. Seems like less than 70. I don't know. There's a lot of CPU intrinsics, I guess. Anyway, so I think because the purpose is a little different, the priority is a little different. You don't know that you get much for making your opcodes hierarchical. You probably do get a little bit when it comes to writing an optimizer, which I haven't done yet. So that's why, I did actually make something hierarchical. What was it? I did it recently. Oh, the segment. So we have segment load and segment store are 2 instructions here. There used to be different instructions for like load from data segment, load from read-only data, load from BSS segment, and load from stack, right? So these 2 used to be 8 instructions, and they're now 2, but then we get the segment out of the data field of the instruction. So yeah. Could just have known ranges. It's true. Like the question is, are there other reasons to organize your instructions in a certain order? So for example, you can see the way that I have these defined. It's actually by which value slots are used. So R was the result slot originally, although now I changed it so that anything that uses only one, even if it's an input value, uses the R slot, so that I could sort them by use, right? But then I realized I wanted more than one sort order because I want to be able to know things by what they use and what they define, right? Now, I think most instructions only define R, but of course, some people don't define it and some people use it only. And then I think like comp exchange 16B like defines 2 things, right? So I guess I'm going to go to a scheme where there's a parallel array with like bit fields of defining and using the different slots. There's 4 different slots max, although only a couple people use the O slot as a register. So then once I do that, there's no more constraint on the way in which these are ordered. And so I would be able to do something like, you know, ordering them for some other purpose. Yeah. I don't know, man. Let me take down the pink text. Okay. What's R or AR or whatever? Those are which fields of the bytecode format does this instruction use as value number representations, which are like the software version of machine registers. Okay, let me go back to here. Find or emit vargs array. Let's make it the name shorter. Okay. So instead of a thing where we push pop these onto different places, we're just going to say what the used ones are on the current stack situation. So we're going to say call site is the emit procedure stack. We're going to turn this into a pointer. Okay. This is going to be the same. Right there. Then we want this loop. Okay, but before we do that loop, wait, I forgot what I was thinking. Okay, we don't remove it. Oh, yeah, okay. We want to check. All right, let's just make a thing. Oh. Okay. Very simple. Okay. Let's call this call. Whoops. Dang it. Okay, so emitting call is I'm not going to say in use anymore because we don't pull and pop them. All right. So already used. Okay. Let's actually even just not do this yet because this should still function correctly. So we're going to go okay. Okay. If we didn't find one, we emit one. And then we make a value number, we make a stack allocation. We don't have used var args arrays. Why am I... I see. So we're, see, we're modifying this thing. I guess we never really... I never really did that. I guess that was in progress. Oh. Right. I was trying to do something there and we couldn't really do it. Okay. Well, although I guess we could make new value numbers. I'm stupid. Okay. Okay. All right. Already used. So the problem is these are by value. But also we don't, yeah, we don't. Emitted vargs arrays. Okay, so we found one. We'll just compare by value number. Now we'll compare it by stack allocation. The problem is because of the type of array we're using, the memory might move, so the pointer's not going to be stable all over a long time. Going to do this. Okay, so already used. Let's do it this way. Emitted vargs array, if it is equal to emitted emitting call is the first argument. Emit procedure stack. Okay, so then push just for debugging. Okay, popping. We don't need any of this stuff anymore, in theory. I probably screwed some things up real bad. Yeah, we don't really need to save that. Oh, boys, guys, my brain kind of fell asleep while doing that. Which means it's going to be amazing. It's going to be amazing. Time for a bacon nap. Yeah, that's basically... Okay, debug compiler. We still haven't done the improved Weissman score. We're just trying to restructure it to get to that place. Okay, so hopefully these are trivial problems. Oh. All right, we have an assert result is not equal to uninitialized result. Okay. Really? How do we do that? Minus 99. How did I do that? Miracle. Okay, let's get rid of this starting basic block index nonsense. It's not going to matter. It's not what the problem was in any way, but we're just getting rid of it. Get rid of it. Okay, so, like what? How are we giving you a minus 99? How does that make any sense? Argument list. Data. Asked to make vargs. Is it the first time that we get here? Yep. Okay. We'll step down. Step down. Asked to make vargs. Oh, do we just not break at the bottom here? No, we do. Probably edited something very badly here. Let's see. Result equals 6. Wait, what? That's a literal. No. Ident. Is it one of these that's messed up? Ident. No, literal. Ident. This all makes sense. Oh, we just didn't set. Okay. Guys, I'm stupid. I thought the thing that was minus 99 was the tag on a thing. It's because my brain is kind of shut off. It wasn't that. It was that we weren't returning the value number. Okay. How is that Weissman score? Is it... Okay, that Weissman score is better, and it wasn't supposed to be. I mean, maybe that's just a fluctuation. It was supposed to be the same. Oh, it's this, roughly the same. Maybe we did remove something that makes it slightly better. So I'll take it. But again, what we're going to do is check this in and then go for the gusto afterward. Okay, this is good. I like this better than what we were doing anyway. Hopefully I didn't screw something up real bad. Okay. Okay. So next up, how big is the executable? Well, no, that's the wrong one. Debug. 15.2. 15.2. Okay. Okay, so we're going to do this down here now. We're going to do that. We're going to go over to the dominating. If we already used it, oh, we need the instruction index. If record instruction index okay. Hopefully I didn't screw that up. So while we have a dominate, we didn't need this local found. We go over all the records. If one of them is already used, skip it. If it's not usable for other reasons, skip it. Otherwise, we finish. Great. We need the instruction index. And then we need to put that on the data structure. Wrong file. This is going to be called emitted. And then emitted varargs array has int there. Great. Okay. Okay. It is a mildly better Weissman score. Really, actually not better at all. Maybe it's not worth having that complexity. Does it run? Okay. So, I mean, it's not nothing. It's just, is it worth the complexity? I don't know. Either way, I'm glad that we rewrote that to work this way because that gives me less of the heebie-jeebies than the way that it worked. Okay. There is one more potentially major Weissman score thing that I would like to do. But because it is major and I don't want to screw it up, I want to do it with a fresh brain. And I'm feeling a little tired now. So we might take a stream break and come back later tonight. This has been a very successful stream. We got 7,000 Weissman score. After last night when things were hard. Things were hard yesterday. That yesterday was right. So we got 7,000 Weissman score. We are a mere 11,000 Weissman score from 100K. Now, the thing with this next intervention that I want to do, it might get us 11,000 by itself. It might not. It depends on what the code looks like and stuff. And it might be very easy to do, and it might be just kind of agonizing. I don't exactly know, but it'll be a fun thing to try. Any final on-topic questions before we take a break? $327 is 25%. Yeah, we might get there, but I think the 336,574 is the closer goal. What is the next step? The next step is dead code elimination in the front end. So like, for example, Sokoban pulls in string libraries. It pulls in a lot of libraries. Like, the thing about libraries is you probably use some of them, but you probably don't use all the functions in there, right? How much of it don't you use? I don't know. Is it 1/30th of your program such that it'll get our Weissman score down? Maybe. Would I expect the link time to stay static over all these gains? Yes, because we're not really doing anything that would add to the link, and we're not really doing anything that would subtract from the link. Although actually we did do something that creates more patches. We might want to think about that. Anyway, but in general, like, the linker doesn't really care about if there's a lot of instructions that don't reference other symbols and stuff. It probably just skips over those. Maybe. I don't know. Is there such a thing in optimizers as seeing identical code in different functions across linked objects and merging them? Maybe. I mean, we don't like linked objects, so we don't think about that. No, if false is already eliminated. What we're talking about is just eliminating functions you don't call. So I think that would be a significant bonus. So my two ideas for potentially big gains are A, do that, and then B, maybe just look at, just dump a bunch of functions again and just look at the code and see if there's anything that seems weird. For the most part, I think things are pretty good now. Like, they're certainly better than they were. Like if we go back to, let's go to like something that we used to dump. So post move reevaluate here. Like if I dump this now, well, let's make sure we run. Just making sure. Just making sure. Okay, so here, okay. Like, this code doesn't look super bloated to me. I don't know what's going on there, though. Is that a concatenator bug? Is that the console being weird? Let me see. That might have been the console being weird. Might have been a very strange compiler bug. Anyway, so if I look at this, I mean, we can look more closely at it, but there's a few things like, okay, like this, assign local declaration to value. This means a value placement is not being satisfied. So that's actually another thing. So it's like most of the code looks fine. There's a few extraneous elements. But like, I mean, this is pretty tight, right? This used to be spam when you did a bunch of calls in a row. And now it's like, like, where is v24 even coming from? It's a 0 from up here. Okay. v5. It's probably 0 of a different size or something. 1. So like, we're doing a good job of reusing our value numbers and whatnot, which is great. How many bytecodes for these two programs? Let's see. We can do that experiment. All right. So for this one, uh, 609. And the reason that's not 0 is because there's stuff in like preload and runtime support that gets compiled into every program, right? But as you can see, it's not huge, right? Sokoban is 300,000. So it's a relatively small amount of code. If we do this, it's going to be a lot more. 10 times as much. Actually, not as much as I thought it would be. But now, ideally, if our thing succeeds this afternoon, these numbers would be equal, maybe. Yeah, it does have to start and end also, but like this actually includes some things. That's actually a good point. I have to flag those things as not getting dead code eliminated. So that's going to be interesting. Can I explain what are the advantages in improving the quality of intermediate bytecode instead of just working directly on optimizing the machine code? It's the same thing as with anything. Like, now again, the second strategy that you mentioned is the one that is in vogue and popular among compiler authors. I think it is very misguided for a number of reasons. One, it is generally true that people in computers are overexcited about the computer's ability to reconstruct complex and subtle information from a bunch of spam, right? On the other hand, when you're generating code, you know a lot about what you're generating. And you know a lot about what optimizations might apply. Or I wouldn't even call these optimizations. These are just more like being less inefficient in the generation, right? So in the process of spewing out, if you go what's the currently in vogue way, in the process of spewing out a bunch of instructions, you're destroying a great deal of information about the context around those instructions and expecting the back end to reconstruct that information. And maybe it can do that, but it might miss some, A. And B, that takes time and resources. Is it any surprise that every single modern compiler is dog shit slow when that's the way they're designed? It doesn't seem very surprising to me. So those are a couple reasons. Also, third reason, again, you want your debug build to be pretty fast. You don't want to have to require an optimization pass in order to run your debug build at interactive speeds, right? And D, just for the purposes of my sanity. So on the one hand, you might think, well, geez, if you're putting all this work, all this complexity into the front end in order to make the code generation better in the front end, that means the system is more complex and it'll be harder to understand and debug, right? That's true a little bit. But when it comes to writing optimizers later, which we haven't done yet, of course, but when it comes to writing optimizers later, it's going to be much better for my sanity if I can look at code that makes sense to begin with and then try to figure out why the optimizer isn't doing the right thing on that code, as opposed to just, code that's much more confusing and bloated, right? Now, that said, in terms of bloat, we're not talking about a huge amount of bloat because we started at Weissman 436. Although even that is, like Weissman 436 was, I would say, significantly more compact than something like LLVM would generate, for example. But we started with that and we got down to so far 350. So, that's more than 10%, which doesn't sound insane, but sometimes those instructions are the one that are really confusing you. Like, why is it moving this thing over to there and then over to there? Like, what? Right? That's all. Wouldn't there be constants in BASIC as well as functions? There would, yes, but those don't add to the Weissman score. Weissman scores only instructions right now. How fast do I expect all the time I spent will be recouped? Well, listen, it's all about the journey, not the destination. So my time is already recouped by seeing how well this project has come out. Can you ensure that, say, a library helper function that is supposed to be called by a user program and is never called within the library itself will not be called dead code? Yes. The way you, so anything that is going to be linked into an object file has to be exported as a symbol, right? Otherwise, nobody knows what to link it as, right? And so there's a way that you do that. There's a program export directive that you use. And so the compiler will just say, hey, if something's being exported from the program, obviously I can't eliminate it because, yeah, somebody might call it 10 years from now, somebody might write a program that links that and calls it, right? So yes, things exported from the program will not get eliminated. Other things will. Yeah, so program exports, using it as an R value, either in procedures or in global scope, right? If you see any of those things happen, you're like, okay, yeah, this can't be dead code eliminated. That said, there is some probability of making a mistake there, but it'll be fixable. So we weren't sure that externing was in. Yeah, it's in. It's been in for a while. Okay, everybody. Oh, is dead code elimination going to slow down the compile time much? My hope is that it speeds it up, but I don't actually know. Because the thing is, at the very beginning, we won't have that many procedures to compile because we'll just sort of have main or something, right? In fact, that's an interesting point. That's actually going to be the most annoying part. Is right now we decide what main is at the end. But we need to decide what main is early on so that we can compile your program. For now, we could just, as a hack, just say anything matching your program name. Let me write these criteria down. So program export, we don't want to eliminate it. If it's an R value anywhere, we don't want to eliminate it in code or data. If it's in preload or runtime support, or if it's main. And we could do a hack initially and just say anything with the same name as your main, even if it's in another module, and then we can revise that. And, so there might even be something we're forgetting off that list, but it's not too bad. Are there considerations for procedures in structs? Right. So right now, if there's a procedure in a struct, I think you can look it up in the struct in the type info. So maybe anything that goes in type info. Isn't it the job of an IDE to remove dead code? No. I mean, that's a different thing. Like if there's a user level interface that tells you what code is not being used, that's a different thing from the compiler not putting dead code into and executable. Not sure if you can actually call it if it's a constant procedure inside. You actually can right now. It's been on my list to maybe revisit that and take it out, but it might be too useful in the long term. I don't know. We will see. The thing is, I think that kind of stuff does make the type info data substantially bigger, and it makes the compiler a little more complicated than I would like. So I'm kind of looking for excuses to get rid of that. We'll see, though. It's for implementing the dead code elimination. I don't think, it's fine. We put that in. We don't put that in. Either way, it's fine. Wouldn't you be able to check that the function pointer of the type info is referenced? No, because that could happen dynamically at runtime. Like if we put the information in the type info, we need to consider it as done. What happens when you divide by 0? Whatever your CPU does when you divide by 0. Why are you doing this manually? Should not there be a mathematically optimal algorithm to do the translation into bytecode? So you're asking, why am I writing a compiler as opposed to using someone else's compiler? I guess. And the answer there is somebody has to actually write the software. Not everyone can use other people's software, right? If everyone uses other people's software, there is no software. You know what I'm saying? Okay, everybody. Let's see who we could raid. We've been recipients of a few raids, so we could see if we could send one back to someone. Science and technology. Pet ducks. Live earthquakes, more pet ducks. What are people interested in here? Roguelike scene game engine. All right. Well, non-English. I'm not going to send everyone to a non-English stream. I self-shave my head. It's very easy to do. I don't see a lot going on here. Programming. All right, it's C#, but it is what it is. Hopefully it's not a porn game. All right, thanks everybody. I'll probably be back tonight, who knows. Uh-oh, wait, it's intended for mature audiences. That seems bad.